Think about your digital life for a sec. It's just this constant stream of documents, logs, reports, tons of text data, right? Now, what if I told you you could instantly transform or maybe clean up or pull out exactly the info you need from like hundreds of files in minutes without even opening them? Sounds kind of like a superpower. Well, today we're doing a deep dive into two, maybe unsung heroes of text processing, Dist and Awk. They might sound a bit obscure, command line things from way back in the Unix days, but trust me, they're incredibly powerful. And they've got this rich history coming from tools like ed and grep. Really sets the stage.
Exactly. And that's really our mission for this deep dive. Because while Sed and Awk are fundamental Unix tools, you're right, the principles behind them, the practical stuff they do, that's valuable for basically anyone dealing with lots of text. Or data, really. So, yeah, we're here to sort of demystify them, show you what each one's really good at, and how they can turn these, tedious manual jobs into automated wins. We'll look at their differences, some surprising things they can do, and lots of practical examples from our sources. Get ready to add some, serious power tools to your info management kit.
Okay, let's unpack this then. Let's kick things off with Sed, S-E-D.
That stands for Stream Editor, right?
That's right, Stream Editor,
Yeah.
and the name tells you a lot. Think of it like a non-interactive editor. Super fast, it processes text line by line as it flows through.
Stream-oriented, like water through a pipe, you said.
Exactly. Input flows in, Sed performs edits on a temporary copy of the line. That temporary copy is called the pattern space. That's key terminology.
Pattern space, got it. And then the result, changed or unchanged, goes to standard output.
Okay, so it's not like Vi or something where you're editing the file directly.
No, not at all. It works on a copy, which is actually a really important safety feature. Your original data stays intact unless you explicitly redirect the output back.
Right. That preservation aspect is key.
It is. And that leads right into a Sed's core strength, automating those repetitive global changes across potentially huge numbers of files.
Yeah, our source material had this great line. Think about making 20 different edits in over 100 files in a matter of minutes. And you get an idea of how powerful Sed can be. That really stuck with me.
It's about programmatic consistency, but scaled up massively.
So things like maybe enforcing style guides, changing straight quotes to curly quotes everywhere.
Perfect example. Or maybe updating a product name or a version number across an entire documentation set.
Things that would take ages manually.
Exactly. It just blasts through them.
Okay, so what are the basic building blocks? What operations does it use?
Well, at its simplest, Sed is great for deletion. You can tell it to delete blank lines, for instance. Or maybe delete a specific range of lines, like getting rid of an email header automatically. The D command...
D for delete. Simple enough.
But the real workhorse, the command you'll use most, is substitution. The ESC command.
Defeat and replace, basically.
Yeah, a supercharged command line, find replace. You give it S, then a pattern to find, then the replacement text, and usually a G flag for global on the line.
Pattern replacement goo. I think I've seen that.
You probably have. It's classic Sed.
And you mentioned some cool tricks with the replacement part.
Oh, yeah. There's the ampersand in the replacement string.
Yeah.
It stands for whatever text was matched by the pattern.
Ah, so you don't have to retype the matched text.
Right. If you want to wrap matched text in quotes, say you just do spattern and G. Very handy.
Neat. And what about grabbing parts of the pattern?
That's even more powerful. You can use escaped parentheses, like and, around parts of your pattern to capture them. Then in the replacement, you use 1 for the first captured part, 2 for the second, and so on.
Oh, wow. So you could, swap the order of things separated by a colon or something.
Precisely. Capture the part before the colon is 1, the part after is 2, and replace with 2, 1. Instant swap.
Okay, that's pretty clever for single-line stuff. But, text isn't always neat. What if the thing you need to match gets split across 2 lines?
Great question. That seems like it would break Sed's line-by-line model, doesn't it?
Yeah, exactly.
But Sed has a way. There's a command, N, capital N, is to append the next line of input into that pattern space, inserting a new line character between them.
Ah, so you create a temporary multi-line pattern space.
You got it. Now your patterns can match across that embedded new line.
Like that example from the source, changing owner and operator guide, even if guide was on the next line.
Exactly that case. N reads in guide, adds it to owner and operator, and then your substitution pattern can match the whole phrase, new line and all.
Clever. A nice workaround.
It really extends what you can do.
Okay, so this sounds incredibly powerful, but also potentially dangerous if you mess up.
Absolutely. One wrong Sed command, especially if you overwrite the original file, could be disastrous.
So safe scripting is paramount.
Crucial. The #1 rule our sources stress. Always redirect sed's output to a new file first.
Sed script.sed input file, output file. Never sed script.sed input file.
Never, ever. Always check the output file carefully. Use diff to compare it against the original.
And the sources mention wrapper scripts, test, and runst.
Yeah, those are fantastic practical tools. Test basically automates the safety check. It runs sed, puts the output in temporary files, and then runs diff between the original and the temp file for every file you're processing.
So you see exactly what would change before anything actually changes.
Exactly. Peace of mind. Then, once you're happy, runst automates the process of actually replacing the original files with the edited versions, usually after making backups.
Saves time, prevents catastrophic errors, seems essential for any serious work.
Definitely. Highly recommend it.
And so it isn't just for basic edits, right? The sources had examples like extracting things.
Right. There's a script, getMac, I think. It used base ed address ranges and the delete command dd to essentially pull out macro definitions. It would print only the lines between a GD's definition start and D definition end marker.
So using ES to filter and extract specific blocks of text.
And the d.outline script was another great one. It took document headings and used substitutions to add indentation and automatic numbering, creating a neat table of contents or outline format.
Transforming structure, not just content.
Yeah, it shows DADS has uses beyond simple search and replace. It can be a text structuring tool, too.
Okay, so Sed is our stream editor, the specialist for fast, repetitive, line-oriented edits and transformations. Powerful stuff. But what if you need more? What if your text file is less like a document and more like, well, data?
Now you're setting the stage for Awk.
The other half of our dynamic duo.
Exactly. If Sed is the surgical tool, Awk is more like the programmable data processor. It steps things up considerably. Awk makes you see text files in a totally different way. It's not just lines anymore. Awk sees a file as, and this is a key concept, a kind of textual database.
Textual database. How so?
It automatically breaks each line, which it calls a record, into fields. By default, fields are words separated by spaces or tabs, but you can tell Awk to use any separator, like a comma for CSV files.
Okay, so records are lines, fields are columns or words within the line.
Precisely. And you can easily access these fields. $1 is the first field, $2 is the second, $0 is the special one that means the entire line, the whole record.
And it gives you variables too, right? Like NF and NR.
Yep, very useful built-in variables. NF holds the number of fields in the current record, and R holds the current record number, essentially the line number. Just having access to fields and these variables fundamentally changes how you interact with the data in the file.
It really does shift the perspective. You're not just editing lines. You're accessing structured data within the lines.
That's the core insight, treating text as a queryable database.
And Awk goes way beyond Exped's simple commands you mentioned. It's programmable.
Oh, yeah. This is where Awk leaves it behind. It's a full programming language, essentially. You get variables, you can define yourself, you can do arithmetic, you have ifelse for conditional logic, you have for loops, while loops.
So you can write actual scripts with complex logic inside Awk.
Absolutely. Think about that student grades example from the source material.
Yeah.
That Awk script wasn't just substituting text, it was reading grades, fields, calculating averages, arithmetic, checking conditions, if grade 90, assigning letter grades, counting students.
All from a simple text file input. That's impressive.
It really demonstrates the leap from text editing to text processing and analysis.
Okay, and there was one feature you mentioned earlier, something about arrays, that sounded particularly powerful for data handling.
Ah, yes, associative arrays. This is, for many tasks, Awk's killer feature.
Associative arrays, so not indexed by numbers.
Exactly. That's the magic. Normal arrays use numbers. Array 0, array 1. Awk's associative arrays use strings as the index, or the key.
So like array my key, some value.
Precisely. Think array name Alice or array count 42.
How does that help in practice?
Consider the acronym example. You could have a separate file listing acronyms and their full forms. An awk script could first read that file and store everything in an associative array, like acrobasic, beginner's all-purpose symbolic instruction code.
Okay, load the definitions into memory.
Right. Then, the script processes your main document. Whenever it encounters a word, it checks if that word exists as a key in the acro array. If it does, boom, awk can print the acronym followed by its definition from the array.
Instant expansion, that's incredibly useful for lookups or mapping data.
It turns awk into this in-memory database or lookup engine on the fly. You can even loop through all the keys in an array using for item in array. Very flexible.
That opens up a ton of possibilities. What about interacting with the outside world? Can awk read other files or run commands?
It sure can. WeSo mostly relies on standard input-output, but awk is more flexible. It has a getLine command. You can use getLine to explicitly read the next line from the main input, or you can tell it getLine some other file to pull a line from a different file whenever you need it.
On-demand file reading. Nice.
Even cooler, you can pipe the output of a shell command into getLine, like whoami getLine user info. Now, the user info variable holds the output of that command.
Whoa, okay, so awk can pull data from external commands too?
Yep. And it can push outwards too, using the system function.system, and can you remind me directory, or
Yeah.
system run another script.esh, right from inside your awk logic.
So it can orchestrate other commands based on the data it's processing.
It's
Yeah.
exactly input, output, command execution. It's quite well connected.
And string handling. Text processing often involves fiddling with strings.
Awk has a rich set of built-in functions for that length. To get string length, index, to find where a substring starts, subscript to extract part of a string, split, to break a string into array elements based on a delimiter, sub, and a g-sub for powerful pattern substitutions, similar to sed but often easier within awk's logic. Match, to see if a string contains a pattern. Even duller and tupper for changing case, which is super useful for normalizing data before comparisons.
Sounds comprehensive, and modern versions like Gawk add even more.
They do. Gawk, G-N-U-Awk, has nice extensions. Ignore case 1 makes all pattern matching case insensitive, which saves a lot of hassle sometimes. And has time functions, like sys down to get the current time and stref time to format timestamps really nicely.
Ah, timestamp formatting. That's got to be incredibly useful for processing log files.
Absolutely essential for serious log analysis, filtering by date ranges, calculating time differences, that sort of thing.
So, awk clearly scales up to handle pretty complex tasks. The sources mentioned full applications.
Yeah, things like interactive spelling checkers, which need to manage dictionaries and user interaction, or complex index formatters for typesetting systems. That filesum script we looked at is another good example of complexity. It parses ls-l output, which isn't perfectly uniform, right? It has to figure out file sizes, skip directories or special files, sum things up. It's doing real data aggregation and filtering.
Much more than just simple line editing.
Definitely shows awk handling more intricate logic and state management than sed typically would.
Which brings us back to scripting hygiene. If awk scripts get complex, debugging must be important.
Oh, absolutely crucial. The same advice applies as for sed, but maybe even more so because the logic can get trickier.
Yeah.
Make copies before editing. Use comments generously. Print variable values. Print debug var to see what's going on.
Trace the execution flow.
Exactly. Comment out suspect lines or blocks, hashtag is condition, to isolate problems. And that idea of defensive programming is key in awk. Check inf before you try to access $3 or $4.
Yeah.
Validate the input looks like you expect.
Prevents weird errors later on.
For sure. And, I remember spending ages debugging a script once, convinced the logic was wrong. Turned out I'd just forgotten a semicolon somewhere.
Been there. The simple mistakes bite hardest.
They always do. But the sources also wisely note you don't always need bulletproof, user-proof script. If it's a quick script for your own use, just get it working reliably enough for the task at hand.
Right.
Balance robustness with getting the job done.
Right. Good practical advice. Okay, so let's try and wrap this up. What's the big picture for you, the listener? We've journeyed through Selland, the stream editor, fantastic for those precise, repetitive, line-based edits across potentially hundreds of files, your go-to for automated consistency. And then we explored awk, the programmable processor. It shifts perspective, viewing text as data records and fields. It brings programming logic, loops, conditions, those amazing associative arrays.
Yeah, bringing that power right to your command line for much deeper analysis, reporting, and data manipulation.
And it's important to stress, these aren't just like museum pieces from the history of UNIX.
Not at all.
The concepts, stream processing, pattern matching, field separation, associative arrays, they're fundamental. They pop up everywhere in modern scripting, data tools, you name it.
Absolutely. Understanding Sed and Awk gives you a foundational grasp of text manipulation that's incredibly valuable, even if you end up using Python or Perl or something else later. Mastering them, or at least getting comfortable with them, is like gaining a new superpower. It's about efficiency. It's transforming tasks that could take hours of clicking and copying and pasting
Yeah, error-prone stuff.
into seconds of running a reliable automated script. It genuinely changes how you approach problems involving text data.
So here's a final thought to leave you with. Think about all those text files you deal with every day. Your logs, maybe CSV reports, config files, maybe even just your own notes in plain text files. What if you started seeing them not just as static words on a page, but as dynamic streams, as data waiting to be processed?
What insights could you pull out? What tedious tasks could you automate? What connections could you make if you started treating that text like your own personal queryable database?
What textual database are you sitting on right now?
Give her and Knock a try. Start simple. You might be surprised just how powerful they really are.